A researcher inputs a raw genomic hypothesis into a terminal interface. This single command initiates an entire automated workflow. High-impact biotechnology research faces a persistent structural bottleneck, the administrative overhead of drafting a manuscript. Compiling references, formatting methods, and structuring extended data sections trap scientists in clerical tasks, delaying the publication of actual discoveries. Standard single-prompt generative AI fails to bridge this gap for two specific reasons. First, generic models suffer from high hallucination rates, rendering them useless for rigorous citation protocols. Second, pasting proprietary pre-published lab data into a public AI prompt presents a severe intellectual property risk, as the data becomes part of the model's public training set. Solving this requires a specialized software architecture, one that isolates proprietary data while delivering a document capable of surviving peer review. OmniBioFex AI operates as a purpose-built bioinformatics engine, utilizing a multi-agent orchestration for scientific rigor. The platform replaces the traditional single-prompt model with an active consensus protocol. The architecture centers around your raw hypothesis. It's immediately surrounded by 4 interlocking modules: the editor, templates, vault, and swarm. These process the hypothesis simultaneously, applying formatting, verifying data, and running compliance checks in parallel to produce multiple academic outputs. We can trace exactly how raw genomic data moves through this specific pipeline, transforming into a finalized manuscript. The process begins in the research editor. This is a zero-cost, distraction-free environment designed for manual drafting and outlining. The moment a researcher types their first keystroke, a passive security layer activates. OmniBioFex utilizes a Google Firestore vault, securing the workspace with enterprise-grade end-to-end encryption. Every word is synced in real time, moving from the editor into a private lockbox. The system enforces a strict stateless rule. AI agents evaluate the data during a session but do not remember it, and public cloud models are actively blocked from accessing the vault. Under these terms, the researcher retains permanent intellectual property ownership over uploaded hypotheses and lab notes. This absolute data isolation is the necessary prerequisite. It ensures scientists can safely input highly sensitive, unpublished genomic data before they ever invoke the AI. Before the AI swarm generates a single word, the researcher must select a specific academic framework. The platform provides over 50 pre-vetted structures, including targeted layouts like the Nature Journal format or the PubMed Central Core. High-impact journals demand rigorous, specific structures. They require distinct divisions for extended data, methodology limits, and precise visual layouts. These templates act as constraints. They passively enforce BibTeX or EndNote-ready citation compliance from the very first draft layer. Applying these structural rules before generation keeps the AI locked on target, preventing it from producing unusable, format-agnostic text. With the data secured and the template selected, the researcher transitions from the manual editor to the full AI research phase. Triggering the multi-agent swarm requires exactly 1 credit, priced at 99 rupees, which yields 1 complete manuscript. OmniBioFex rejects standard monthly SaaS subscriptions in favor of a pay-as-you-go model. This server load chart explains why. A flat baseline covers the manual editor, followed by a massive vertical spike. This peak maps to the heavy API compute required to deploy the AI swarm. Because this expenditure is non-recoverable, we enforce a strict no-refund policy. However, purchased credits never expire. They sit in the account as digital assets until the researcher is ready to deploy them. The pricing economics directly reflect the industrial-grade processing power required to automate an academic paper. The moment that credit is spent, the compute trigger is pulled. The prompt immediately splits into the Grok-powered multi-agent swarm, activating 3 highly specialized nodes: the bibliographer, the methodologist, and the editor. The methodologist node analyzes the raw input data to construct highly structured experimental lab steps. If the input involves a complex physical protocol, like off-target analysis for gene editing in this CRISPR tube, the methodologist organizes exact titration parameters and validation steps. Through active consensus, the nodes cross-verify their work in real time. The methodologist sends claims to the bibliographer, which checks data against PubMed and returns verified citations. Finally, the editor node synthesizes these verified technical steps and accurate citations into a fluid academic narrative. By forcing multiple specialized nodes to cross-check every claim before finalizing the text, the platform actively suppresses the hallucination rates inherent to single prompt models. The swarm acts as an automated internal peer review panel. Once consensus is reached, the agent swarm collapses its work back into a single unified document. The output delivers a complete end-to-end structure: an abstract, introduction, materials and methods, results, and perfectly formatted citations. Looking at the document structure, we see the integration of dynamic bentile layouts. The system automatically segments modern scientific data visualization, like scatterplots and bar charts, into designated clean zones. This ensures the visual presentation of the data matches the strict academic rigor of the verified text. A finalized layout like this traditionally takes weeks of manual formatting to achieve. Upon completion, the stateless AI clears its cache, and the researcher retains full intellectual property rights for the publication. The document is immediately available to export as a PDF, a Word document, or a LaTeX file. The newly exported file is now completely and structurally ready for immediate journal submission and rigorous external peer review. We started with a raw genomic hypothesis, bottlenecked by the administrative burden of academic formatting. By delegating the friction of citations and structure to a secure, multi-agent workspace, OmniBioFex AI allows researchers to return their focus to where it belongs: actual scientific discovery.